Using prime factorization. To find the least common multiple of larger numbers, we will, step 1, find the prime factorization of each number. Then we will identify all the unique factors. Then we will assign the highest exponent to each factor. Then the final step will be to multiply the unique factors with their exponents together. So let's go over an example. Earl is undergoing chemotherapy to treat testicular cancer. Earl's doctor has ordered that his chemotherapy consist of a minimum of 36 units of etoposide and a minimum of 24 units of cisplatin. If Earl needs to have the same amount of each drug at each treatment, what is the least amount of chemotherapy drugs that Earl can have to treat his cancer? So, what we will first do is find the prime factorization of each of the numbers. So 36 can be broken down into 2 and 18. Then 18 can be further broken out into 2 and 9. 9 can be divided by 3 and 3. And these will give us the prime factorization of 36, which is 2 to the second power. So we have 2, and then times 3 to the second power. Now 24 can be broken down into 2 and 12. 12 can be broken down by 2 and 6. And 6 can be broken down into 2 and 3. So we would have 2 to the third power times 3. So the next step will be to assign each factor the highest exponent. So for this we have 2, which between these two numbers, the third the 3 is the highest exponent. So we would write 2 to the third power. Next we look at 3, as it's the next unique factor. And we notice that 2 is the highest factor. So we would write it to the second power. The next step will be to multiply these out. So 2 times 2 times 2 times 3 times 3 is equal to the least amount of chemotherapy drugs to treat Earl's cancer. So 2 times 2 times 2 is equal to 8. 3 times 3 is equal to 9. So we would just then multiply 8 times 9, which is equal to 72. So this is our final answer, 72. Now let's look at another example. Frank has been placed in remission from testicular cancer. Remission means that the cancer seems to be gone. However, Frank will still need to visit his doctors regularly to ensure that it has not returned. Frank will need to return to visit the oncologist every 12 months and return to his primary care physician or regular doctor every 50 months for follow-up visits. When will Frank be required to visit both doctors on the same day? So for this problem, we're going to find the prime factorization of each of these two numbers. So 12 can be broken down into, we can divide it by 2, which is equal to 2 and 6. And then 6 can be broken down into 2 and 3. So the prime factorization is 2 to the squared times 3. Now 50 can be broken down into 2 and 25. And then 25 can be broken down into 5 and 5. So this one, prime factorization is 2 times 5 squared. Now we will assign each unique factor to its highest exponent. So the first unique factor is the 2. So we would write 2, and the highest power is 2. So it would be 2 squared. Next, the unique factor is 3. We don't have a 3 in the other one, so we'll just write 3. The next unique factor is 5. So 5, and we see it's raised to the second power. So then when we multiply this out, we get 2 times 2 times 3 times 5 times 5. And this is equal to, so for this multiplication, let's first multiply. 5 times 5 is equal to 25. We'll have 3, and this is equal to 4. 2 times 2 is 4. So then we multiply these out. But let's further multiply. 3 times 25 is equal to 75. Then let's multiply it by 4. So the way we would do that is 75 times 4. So 5 times 4 is equal to 20. Carry that 2. 4 times 7 is equal to 28. Plus the 2 is equal to 30. So we have 300 as our final answer for the month that he will see both doctors.